A prompt is not enough. If an agent only generates text, a bad prompt is annoying. If it uses MCP to call tools, read files, query databases, or control external systems, it becomes an access problem. Many agent demos skip precisely this issue. The Model Context Protocol connects AI applications to external systems. MCP servers can provide tools, resources, and prompt templates. Tools do more than provide context. They are executable functions. An agent can call them to perform actions. What the agent should do is no longer the only concern. What matters is who may do what, when, and to what extent. It also matters how users can revoke that access. Better system prompts and clear rules help, but they are not a security architecture. Prompts guide behavior, authorization limits capabilities. MCP divides the architecture into participants and layers. The MCP host is the AI application. For each connection, an MCP client maintains the connection to an MCP server. The server provides context or tools. The transport layer handles connections, message exchange, and authentication. Remote connections support standard methods such as bearer tokens, API keys, or custom headers. The MCP documentation recommends OAuth for obtaining authentication tokens. This matters because agent orchestration works differently from traditional software. Modern agents can plan, use tools, and delegate tasks to specialized agents. The OpenAI Agents SDK describes these patterns using tools and handoffs. The model can control the process, or code can orchestrate it more deterministically. Good prompts, monitoring, and evaluations remain important, but they cannot reliably decide whether a tool may access an account, database, or calendar. Treat tool access like product access, not like a paragraph in a prompt. Keep permissions as narrow as possible. An MCP server should not automatically have every permission simply because the agent knows it. Reading a calendar differs from deleting appointments. Reading a database schema differs from having write access. An agent needs roles and clearly limited scopes, not merely trust. Make user consent visible. If a remote MCP server needs account access, it belongs in an authorization flow. Users must be able to see what the agent can access. A hidden token in a configuration file is convenient but difficult to control, separate discovery from execution. An agent can list available tools without immediately being allowed to execute them. This is especially relevant to MCP because clients can discover tools dynamically. A visible capability is not permission to use it. Plan for revocation as well. Anyone granting an agent access needs a clear way to reverse it. Tokens must be able to expire. Access must be revocable. Logs must show which agent called which tool. Orchestration and authorization are separate tasks. Code orchestration can make processes more predictable. Model orchestration can solve flexible tasks. Both share the same hard boundary. The agent can decide which tool would be useful. The architecture decides whether it may actually execute that tool. MCP makes agents useful by giving them tools. That is precisely why security becomes more important. Better prompts reduce misconduct. OAuth, limited permissions, consent, and revocation limit the potential damage. If your agent can interact with real systems, the crucial question is not, is the prompt good enough? It is. Is access properly authorized? Share this with your team to save time.